Hello and welcome to India AI. Today in my conversation, I am joined by a very young genius boy, all of 7 years, who holds the Guinness World Record for being the youngest computer programmer in the world. But that's not all, because this wonder kid also knows a great deal about artificial intelligence and machine learning, topics that even grown-ups like us would easily be intimidated by. In fact, he's been a speaker at various international conferences, including the upcoming Malaysia Tech Month and the World AI Summit in Amsterdam this year. So sit back and prepare to be awed as I present to you Kautilya Kataria. How's it been going? How's mom and dad and your little brother?
It's been good.
All right. And I think you have there's so much fun stuff lined up for the break, isn't it? You have this conference that you're speaking at, and your dad told me that you'd been preparing for that.
Yes.
Which one is it?
It's a Euro-Python conference.
It's the EuroPython conference. Okay. What is it about, and when are you speaking there?
It's about computational complexity.
It's about computing. What do you know about computing? Why have they invited you? Do you know a lot about computing? That's why they invited you. Oh, wow. What all do you know? Tell, what is computing?
Computing is basically doing stuff with a computer, basically.
Oh, right. What kind of stuff can you do with the computer?
Well, for starters, I can code, and
you can code. That's so cool.
And I can open Google Chrome. Of course, like just.
Wow, you're a smart kid. We all know that. What kind of coding do you do though?
So when I started coding, I used to do HTML, CSS, Python, and JavaScript, but now I only do Python.
You only do Python, and why is that? Why did you get rid of all of the others?
I only do Python because it's really easy.
It is really easy. Okay, so do you think that most people who want to start learning coding should start with Python because you think it's the easiest?
No, it's not easiest. First block level computing languages like Scratch, and then real computing languages like Python.
Oh, so you think someone who wants to start should start with Scratch then?
Yes.
And then move to others like Python?
Yes.
But how do you think it compares with other languages?
It's so it has lots of artificial intelligence libraries, and it also is really fun.
Okay. And artificial
it was actually made to be fun.
It was made to be fun. Oh wow. That was the intent behind Python? It was supposed to be fun?
Yes, I think.
Wow. And artificial intelligence especially, I think Python works best for that kind of coding.
Yes.
Yeah. And you know, artificial intelligence is one of my favorite subjects. Can you tell me a little bit about that?
So artificial intelligence is basically making a machine have intelligence. Like so it almost represents a human brain.
Okay. So but aren't machines intelligent naturally? Isn't that the basic function?
No. So first a person needs to program the machine, then it can be intelligent.
Oh, so but is there a difference between intelligent machines and stupid? Are there any machines which are like stupid, which aren't intelligent? What do we call them? Stupid machines then? Let's talk more about AI, okay? You said that it makes machines artificially intelligent, and you said that you code. And I remember the other day you were talking to me about some algorithms also. Maybe we can talk about that a little bit so that I can know more.
Okay.
Yeah.
So you mean some algorithms that which use artificial intelligence?
Yes, that would be nice. That would be nice.
So I think K nearest neighbors is an algorithm that uses artificial intelligence, and it finds the K. So it's basically finds the K nearest neighbors to a point on a graph. I don't mean a graph. I don't mean a graph as in a graph with a line. I mean more like a scatter plot where there's dots, basically.
Right, right. How do you know all of this like big tech stuff about computing and AI and algorithms? Where did you learn this? And at such a young age?
How I started learning coding was when my dad gave me this book that I really loved, and it was about computing, and I loved it so much I finished it in only one day and actually built some basic computer programs and also installed Python.
Wow, you read it in one day.
Yes.
To me. Do you remember this one thing that I really loved that you told me the other day? You said that computing is like solving puzzles.
So computing is like solving a puzzle because the operations are like the pieces to make the puzzle into one to solve the problem.
That's very smart. How did you figure out this analogy? Like, was it something that struck you when you were probably solving a puzzle? How did it come across? That's really smart, I have to say. What class are you in now?
A2, 2SB to be precise.
Okay, and
the SB stands for Sophie Price.
Okay, so in the last let's say two or 3 years that you've been interested in AI and computing and all of these things, what are some of your favorite things that you've learned? And tell me.
One of my favorite things I've learned about is IBM Watson.
Let's talk about that then.
You know that artificial intelligence thing that actually beat Ken Jennings in Jeopardy.
But that's so cool, right?
Yeah.
Wow. Do you think you'd be able to build something of that sort and beat some other computer program with one of your algorithms? Is that something that you want to do?
Yes.
Wow. But I think you have built also. You've already worked on a little on a few programs, etc.
Yeah, like that programs that can detect if there's fire or water or smoke. I used IBM Watson to build it, and I think it's image recognition. And also I think it could be used in places where there's a high risk of fire, so that the camera can be connected to my AI model, and then it can check if there's fire or smoke. If there is, then it can use the email or call a firefighter. I provide lots of data. So some data to describe fire, some data to describe smoke, and some to describe neutral.
Right. And then that's how you train your model, right? You give it a lot of data and then you train it. And then you apply it to a real life situation.
Yeah, and that is the step that I'm probably going to do when I'm a teenager.
Oh, that you'll do when you're a teenager. Oh, you're waiting to get older so that you can do more stuff with it, right?
Yes.
But what is data, Kautilya? Well, like data is like, it's a very fun word. Can you help me understand what is data?
So you basically have a lot of values and stuff. And so a lot of values, that's one-dimensional data, but if you do two columns, then that's two-dimensional. And if you do three columns, that's still two-dimensional, and so on. But if you, yeah.
Oh, that's data. But like data is basically what? Like, is it a lot of numbers only? Is that all what data means? Numbers?
No, it's not only numbers. It can represent images or numbers, Morse code, text.
All of this can be data.
Yeah.
So then there must be like a lot of data, right?
Yeah. And in fact, there are 30 trillion pages on Google, which is, and also there's 1 billion gigabytes of data on Amazon.
Wow. And where do they keep all of this data?
They keep.
Like, can I catch like data in the air if I look around? Is there so much of it?
So they keep it in a model to, like in Netflix, they keep it in a model to see what you most like, and then the Netflix can give you some recommendations.
What is it called? What is this AI? What sort of AI is this recommendation model?
I think it's either machine learning or deep learning.
Oh, it's one of the two.
Yeah. And if it is machine learning, then it's probably supervised learning.
What is the difference between machine learning and deep learning? It sounds so similar.
The difference between them is deep learning is so the more the data, the better it gets. But if you do another model like machine learning, then it's kind of like a log graph. So it goes like this, and while deep learning goes like this.
So it's the difference in the graph.
Yeah. Yeah, basically, I think.
Okay, and then you said supervised learning. What is that?
So supervised learning is a type of machine learning, and there's also two other types, unsupervised learning and reinforcement learning. So supervised learning, you give data with the labels. Unsupervised learning, you try to get the labels with unlabeled data. And reinforcement learning, you learn with trial and error, just like a human.
Okay, but you also, I remember that you were talking about some of your favorite algorithms. You said there were two favorites. You had binary search and time sort, was it?
A stem sort, and also now I have two new favorites: interpolation search and smooth sort.
Let's talk about these. What are these? I want to know about all four of these now.
So binary search is where you keep on dividing the data into half, and if the input is on the left side, then you ignore the right side. If it's in the right side, you ignore the left side. And how you check if the data is in the left side or on the right side is so for this you need the sorted data. So you check if you check if the input you check if the element you want to search for is less than the element which is halfway across the data, and if that is true, then ignore the right side, and if that isn't true and also isn't the middle element, then you search left, then you ignore the left side.
How did it come to be your favorite? Did you use it somewhere, or did you see it used somewhere?
That's my favorite because it's the fastest searching algorithm. Actually, it's the it is
it's the fastest searching. That's why it's your favorite. And then what about the other ones, other favorites?
and then there was interpolation search, which is the fastest algorithm in the average case.
Oh,
So
that's another search algorithm.
yeah, so it's when the data is uniformly distributed, it works best. So when it's like 2, 4, 6, 8, but it can't be like 2, 3, 9, 18, 2,055 million.
Okay, but all of these algorithms now, are they only used, is it only very theoretical, or are they being used somewhere for practical purposes in real life also? Do you know if they are being used in the real world?
I don't know, and also I don't explain smooth thought. Actually, I don't really know what smooth thought is, but it is my favorite. Once I knew it's time complexity and space complexity. So its time complexity is omega of n, theta of n log n, and O of n log n. That's the same as Tim thought. But its space complexity is order of 1, while binary search space complexity is order of m. So, not binary search, I mean tensor. And
So this,
also, you know, like Google and Amazon also use search. Also use search algorithms to search for to search for the what you type in the search bar.
oh, so to predict?
No, not to predict. It's to actually search the data it has. And
Oh, right. So you mean when I search for something on the Amazon website, it will use AI to search? Is that what you're saying?
no, we will use search algorithms to search.
Who taught you all of this, Kautilya? Do your parents help you learn all of this cool stuff?
Yes.
Yes?
Yes.
In what way? Like, do they teach you? Do they know coding as well? Or do they only bring you these books and then you read and learn yourself?
They mainly do the books, but my mom also helps me solve the problems.
Oh, she does. Wow. And your dad helps you too?
And my dad helped me to buy more books.
I think that's a perfect combination. One of them is getting you the books, one of the other one's helping you solve these problems, and then as a result, we have a very smart kid, don't we?
Yeah.
Okay. Okay. I think now we should. I want to see this. Some of the things that you built. Let's talk about all that you were able to build using AI. You told me that there was this IBM chatbot that you did. A chatbot that you built using IBM Watson.
Yes, and it's on my website.
Okay. Do you want to show me?
Okay.
Okay, please.
So do I share the screen?
Yes, you can share the screen, please. You have a website. That's so cool. Who made this for you?
I made it myself. And also here's the chatbot. So can I type some stuff into there? It'll take a second or two.
Oh.
Okay, time for the big output. Boy, Python. Ready. And then fun. Bye.
Wow. But did you, so no, tell me how it works. So if I want to build a website for myself and include a chatbot in it, will I have to tell the chatbot what it has to answer to every question? How does it work?
So yeah, it's kind of like that. So you first need to go into your IBM Watson cloud, which is the website is cloud.ibm.com. And
you can stop sharing now, I think, and so that I can see you a bigger version of you on my screen.
Okay.
Thank you so much for this, for showing me. Okay.
So So you can go onto IBM Watson, then you can sign up, and then after that you can create a new chat bot. I don't know what it's called in IBM Watson, but you can create a new chat bot, and then after that you can add some intents, and then the entities, if you want to add some entities, and then you can add some dialogue, and then the dialogue will actually tell the answers, and yeah.
But do you have to feed all of these answers into it? Or does it know intuitively?
I have to feed all of the answers, but not all of them. I mean, just like, yeah, some of them.
So if I ask it something that you haven't already taught it, it won't be able to answer?
Yeah, but if you tell it something related to it, then it can answer. Actually, that's why AI does.
Right. And does it keep getting better with time? Does it keep learning?
Reinforcement learning does, but IBM Watson uses supervised learning, and supervised learning doesn't.
Oh, so this one, so okay. But is it possible to build chatbots with reinforcement learning so that they keep getting better?
Yeah, I think.
And then I think one of the other things that you've recently learned about is the big O notation.
Yeah.
Let's talk about that. Yay.
Okay, so big O notation is nothing but forget about small and think big. So you first ignore all the constants in its worst case running time. So if the worst case running time was log n plus 1, which is for binary search, then it would turn into only log n. Then remove the multiplicative factors. There's no multiplicative factor of log n, but let's say another one. How about n squared plus 5 times n squared plus 2. So remove the constants, so 5 times n squared, and then remove the multiplicative factors, which will make the expression n squared. So that program's time complexity is n squared, is the order of n squared.
Oh, wow. So big O notation gives you the time? It gives you the time that it takes?
No, it's basically an approximation for the number of steps it takes. Why approximation? Because big O notation actually does it for large inputs like 1 billion, trillion, million, quadrillion, quintillion, maybe. Okay, so and also so
yeah. And okay, Kautilya, tell me. So what is there something that you dream of building using AI and computers and all of that, all of these technologies?
Yeah.
What would you like to build?
A robot that can turn into anything, almost anything, except solve the Turing problem. The Turing problem is like to write a So the Turing problem is you write a program. You write a program to check if another program runs correctly or not. So if it doesn't throw an error.
Okay, but do you not want your robot to be able to solve the Turing problem?
No. Actually, no computer can solve the Turing problem, even if there's going to be 1 trillion times faster computers, or maybe even 1 trillion times the fastest supercomputer. And there's actually a supercomputer which is trillion times the second fastest supercomputer, but I'm pretty sure not even that supercomputer can solve the Turing problem. And also going back to stupid machines. I think I know one.
Okay, tell me.
A mouse is stupid.
Oh, yes, you're right. Actually, you're right. What about like my phone? Is it a stupid machine too?
No, it isn't because
No?
yeah, it isn't because it has Google, it has Amazon, it has and also some phones also have Alexa in them or Google Assistant.
Right. Okay. So these AirPods, for instance, are these stupid?
Not if they're connected to your computer, but if they aren't, then they are stupid.
Okay. No, that's very smart. Like I have like a speaker lying here. Is that a stupid machine? Like a sound speaker?
The same. It's like the AirPods. So if you connect it to the computer, then it isn't stupid. But if you don't, then it is stupid.
And then it's stupid. Okay. Okay. Wow. What are some of your other examples? What is your favorite intelligent machine?
My favorite intelligent machine is a robot.
Is a robot. Have you ever seen one in real life?
No.
Do they not come? Have you not seen those delivery robots that come around every once in a while?
Yeah.
See?
Yeah.
How does that work? How do they come to you and how do they deliver stuff?
They use image recognition to do it, and also did you know that sometimes some of those delivery robots I don't know if this is true, but one of my classmates said that one of the delivery robots waited for like 5 hours to go even after the car had gone.
That must be a stupid robot then.
Yeah.
Please, when you make your robot, make sure that it's very smart. Make sure that it doesn't wait 5 hours. Will you build this the fastest one? I think you should build the fastest one that ever has been.
Okay, I think I have an idea what to make it out of.
Okay.
It's either aluminum or carbon nanotubes. Carbon nanotubes when scientists figure out how to make carbon nanotubes longer without destroying their strength.
Mm-hmm. Okay, so you have a fair idea of how you want to go about building your dream robot.
Yeah.
Okay. I had a few friends, Kautilya, who are also your age, and they wanted to start learning about all of this computing stuff. So how do you suggest that they begin?
So I suggest they begin by scratch, and then after they figure out a lot of stuff how to program in Scratch, then they can move to Python. And
Okay.
yeah.
And do you think that it's possible for people for kids as young as you to learn it? Do you think it's easy to learn?
Yeah, it's very easy.
It's very easy?
Yeah.
And is it a lot of fun too?
Yeah. I could have started coding when I was even 4.5 years old, which is just 1 year before I actually started learning it.
Oh, but does it not require a lot of mathematics?
It doesn't require a lot.
No, because a 4.5 year kid.
You just need to know about subtraction, multiplication, addition, and division, and the modulus operator.
That's it. That's all you need to know?
Yeah,
Not much.
yeah, it isn't much.
Isn't much. So I think I'm gonna tell other friends.
Wait. Also, you need. So when you get older, and you get to start, and when you start solving problems, then you need to then also you also need to learn about the log operator.
Okay, okay. I see, I get it. I get it. And then I'm just yeah, go on. Go on.
And also if you want to but it would take a lot of math if you want to learn all about the math library.
Okay.
Like it has like how to figure out being factorial, log, and also the power off and a lot of stuff.
Okay. Okay. I know. I'm just reminded of speaking of robots and AI. I'm reminded of self-driving cars. Do you know what those are? Have you ever seen one? What are those?
So self-driving cars use image recognition again to find if there's another car coming through, and if there is another car, then they automatically stop, and they can also look at the traffic lights. Look at the traffic lights.
Can you build one using the AI that you know? Is it easy to build one of those?
The hard part is making a car. The easy part is making a model.
Okay, so actually manufacturing the body, etc. of the car is tough, but making the model you think is easy.
Yeah.
Okay. I think we've spoken enough for the day. Is there anything else that you want to talk about?
No.
No. All right then. I think we can bring this to a close, can't we? All right. Bye.
Bye.
Bye.